Okay, so today I'm going to talk about mocking the UART in C++. So we have some keywords here. I don't know who of you knows what UART is. Yeah, most of you, I would say. Yes, good, good. And what is mocking, but then we will discuss this. So, at first we will get to know each other, or at least you will know me, and we will discuss 4 topics very briefly: CAS, Yocto, QEMO, and RISC-V. Very briefly, because this is not a conference about embedded, but that's about C++, so we will just do this very briefly. And then we will just introduce C++ immediate functions and how we need this in our cases. And then an interactive demo. I'm not sure we are going to do this, but let's see. We will see. So, about me, I'm the head of the Competence Center IoT and Embedded Systems at Adesso Schweiz AG. I'm co-founder at Italian Embedded together with Lorenzo. And I'm hosting the user group C++ Lugano. And I gave some very brief, small talk before at Embedded Online Conference, at Embedded Conference, Computing Conference, and Italian C++ several years ago. And since January, I'm also part of the delegation of C++ Standardization Committee, the Italian delegation. So I'm very sorry, that's not about me now, it's about you. We are just after lunch, so it's important that you interact a little bit, otherwise you fall asleep. So let's try to do this. So raise your hand if you know at least 3 logos of this. Yeah, I'm really surprised. Very good. Yeah, we will then discuss why you know at least three logos, but that's okay. And now, again, 3 logos of these new ones, developments. Keep your hand. And now? You see the difference? Okay, just joking, to double check that you are not already sleeping, but yeah, that's okay. And about this, it's a little bit more complicated, I would say. Yeah. Yeah. It takes time, but yeah. On the left part, they already sleep. I see no hands raised. And then this one. So I would say, yeah, should be everything. Every one of you. It's just hyperscalers and containerization technology. Okay, now that we know a little bit what we are going to discuss today, we are not deep in dive into any of these, of course, maybe just a little bit, but that's basically what we do as embedded engineers in 20 years of career. It's not every day working. Of course, you cannot work every day with everything here, every logos. Maybe you work with only few of designing, prototyping, of development, and testing, of course. Okay, so now it's complicated. Who knows CAS? No one. That's good. 1, okay. So basically, Yocto project is a framework to build a Linux distribution that are custom, so you can decide from scratch, from 0, from the kernel, what to add on the image. The community is working very hard to improve the quality of development life, or developers' life. So at the moment, it's a little bit complicated, and Siemens created this CAS software just to get this building process easy. So you can just add layers of software that you want, customization that you want in an easier way and reproducible way, because that's important that we always think about our software in a continuous integration way. So we should commit something somewhere, and some machine should build everything for us. And this CAS software is helping us in doing this. And then there is this Yocto project. Already I spoiled a little bit what it's about. It's about creating custom Linux distribution, basically. And QEMO is the emulator and virtualizer that runs within the Yocto project, but of course it's a separated project, so you can just work with it. And on your machine, I have a Mac with M4. You can work with the RISC-V, for example, with ARM, with Cortex M4, whatever you want. And then there is this RISC-V. It's just an open source version of MCU development. It's just a community in the electronics industry decided that they didn't want to pay any more loyalty, or not loyalty, sorry, but anyway, fees to ARM, so they decided to design from scratch a new architecture. Very similar to the other one, but a new one. Okay. So I just shared with you these 4 technologies, and now we are just going to use them. We create a YAML file to import a recipe that is bare metal hello world. Bare metal, now we are going to define together what bare metal is. And then we use DevTool, that is a tool inside Yocto. We use BitBake, that is basically the Ninja or Make in general. So it's leveraging and is building your software, and then we will run our image on our laptop. We will see if we are going to do this interactively or not. So this is basically the software. The other name of Yocto project is Pocky, just the friendly name. We are still on an older version. That is Kirkstone, is the branch name you see over there. And then we will see that we want the version of libc that is bare metal. So we don't want to use any specific libc in our environment. When we say bare metal, this means that we have no STL. I think this will be the only talk today that is not leveraging the standard library. But yeah. Here we are just seeing that this, how Yocto works. So you are including a lot of layers, over layers, and you are creating from zero a new Linux distribution. But let's go back to our topic of today. So here is how you build it, and at some point you will run on my machine, that is a MacBook. We will run something that is really built for a RISC-V, and you can do it for basically whatever you want. The good thing is that you can, of course, do the same on a continuous integration. So you can do it on your machine, and then you can commit it. Someone will approve, maybe yourself, maybe someone else, and you have the same process on the continuous integration that is virtualized, so you don't need a physical device. Of course, at some point we have always a physical device, and we always test a physical device into the continuous integration, but that's another story. Okay, so first of all, why we are doing this mocking? So we want to test a software in isolation, and me personally, I travel a lot, so I need something that I can run on my laptop. I cannot go in a flight with some cable coming out from my laptop attached on a PCB on my backpack. I would really create panic on the flight. So I cannot do this. And on the train is the same, of course. So I need something that I can run on my own laptop for when I'm traveling. And now we are introducing another story that is about C++ immediate functions. Before we talked about const exp. Now we are going to push a little bit more. There is a fact. 20 years ago, in the University Polytechnic of Milano, we used to say, if it builds, it works. And now it's for real, because now we have Consteval. So if it builds, it works. Everything is done at compile time. Everything, yeah, we will see. So what is an immediate function? It's something that is guaranteed or must produce a compile time constant. Here we have a very brief example. Of course, the imagination is not that good, but anyway. We have this example from CPP reference. Constexp is working with constants and runtime variables, and it compiles. But if you define this new function as consteval, then you should give it a constant. That's a requirement. So, for example, if you just pass argc as an input, this is a variable, and it depends on the argument that you are passing to your process. Of course, you have an error, a compilation error. Okay, so let's go through this one, this specific topic. So this is a bare metal firmware. That's all. You don't need anything else. Okay. This virt UART 0 is your register that you can write to and you can read from. And then we have this volatile unsigned int star const. Who knows why volatile should be there? I think most of you should, but.
Because it can change from external sources.
Yeah, everything that is related to a data register can change without you saying something or doing something, so you cannot change it at the compiler cannot change the behavior of this. For example, by removing it altogether. That's an example. And then we have this printing function. Basically, it receives a string pointer, and one by one is just assigning this to the peripheral. So you have this serial connection that is receiving your char one by one. That's the only way you can do it. I don't know if you ever saw a print function before, but that's the only way you can do it. We are not using print from the standard library. We are not using print from the C standard library. We need to do everything from scratch. Because in this case, in this specific case, we are in freestanding mode. I don't know if you know this part of the standard, but this means that you have nothing. You don't have a string.h, you don't have C-string, you don't have a string at all, you have nothing. You should build on your own. So that's basically the key point of today. We have this. We want to dereference our data register, and we want to assign it something. In this case, an assigned int, but it's basically a char. Now, we have a problem here. And that's a problem not about this code, but about code in general that we always have when we want to test something. Can you spot what is the error here? Not the error, but it's about design in general. We want to test this print UART 0 function. There is? There is no main. It's a good one. Actually, when you are freestanding, there is no main. So you have the linking script that is saying that your C entry function is your main, basically. Yeah. That's a good one, a good point. I didn't tell you this, but it's important to mention. Other issue? So the answer is bound somehow to the specific address, right? And that's a good point. So in particular, the print UART 0 is leveraging a global, and you cannot test it in any way. So you want to change this input of this function whenever you want to mock this behavior of your system, okay? And that's how you fix it, basically. You just change the print UART 0 in a generic print that is accepting a UART device. In this case, it's a device, it's an address, whatever you want. The define is not important here. We want to have in our main function the definition or the transformation of a device address into something that we can use, and we change the print function because of this. So now we can change the input, and we can write tests that are trying to check edge cases, for example. And this part of code is the same. So we want to have the ability to dereference this address and to assign it a char. Okay, that's the first iteration in a sort of TDD way. Let's call it this. Actually, I did it in a TDD way, so, but now it's just impossible to do the same. It took me some hours of work, together maybe even more. So, just because of interaction between people that are discussing all these topics. So we have this example. We are introducing a mocking struct, a struct that is mocking a UART device, and we want to dereference, as I said, and we want to assign something to it. Even here we have a couple of issues at least. Who can spot them? Yeah. We don't test anything, right? You said? Yeah, true. We are just returning true, nothing else. So we are adding coverage, but we are adding false coverage because we are not checking everything. And we are checking nothing here. The other issue is the compilation issue, because of course the structured mock UART does nothing. So we are still missing the operands, the referencing and assignment operator. But then we are also returning true, as was said here. So now we are adding these operators to improve this. The return true, then at the end we will see how to improve it. But here we are just adding this operator that is just returning itself. That's completely okay. We are testing. We don't need nothing special. We need nothing special here. And we are adding this operator equal that is doing nothing. We are able to build it. Of course, the tests are not that useful. And now the next step is that we want to use our function. That's basically all this experiment is about. We want to be able to build it. We want to be able to test it. And if this is at constant compile time, then we are already done. And of course, then we will check also at runtime. So even here, we have another issue. Now we improved the mock UART. Now we are able to dereference it. We are able to assign it something. But then I don't know if you remember the print function. Let's go back a little bit. Yeah. The print function is accepting a volatile unsigned pointer. So this is still not compiling at all. So that's basically the error that you will see. We are passing a mock UART struct, but we are expecting a volatile unsigned int. And here the solution is very easy. You can just generalize your print function, and you can accept whatever you want. Of course, here we can use concepts, we can use whatever you want. But here, it's just to give you this example. Now, by generalizing this function, you can not only test one UART, you can test all the UART that you have. Maybe you have 4 UART on your device, and you can mock it. So you can just test edge cases by adding mocks or mocking behavior. And that's the very last part. So here, what we want to do is still at compile time. We are just creating a string. We are just providing this string to the print function. And by creating a mock UART struct that is able to save somewhere this information that you are passing to it, you can just save it, and you can just check if this is okay for you. And as you said, as you can say, now we are not just returning true, but we are returning a string compare that is just comparing the expected and the actual, okay? But now we have still another issue. Of course, as usual, we are C++ developers, so we know that we have always issues. This string compare function, how this can behave, or at first, this will compile at all or not? As I said, we are in a this is not const eval, and we are in freestanding way, so there is no string compare. That's also a point. Even if we add it, it's not const eval, so we cannot leverage it. We should create a new string compare version that is const eval. There is already some work on this, of course, and there is a lot of work on the freestanding itself that is able to use C++ in a very tiny MCUs. But here, we basically needed to create our own string compare. That's what we did. And now we have a real test. Eventually, we are able to call our function and check the outcomes of our function. So what we can do is, on our flight to Dortmund, I don't know, we can work on our own laptop without worrying anyone. And we can create everything. And if it builds, it works. I know that's a little bit of a claim, maybe too much, but yeah. And of course, we should come back to the runtime. Yeah, there is a question, yeah.
Why would you care that your mock is still freestanding? Like, it's a mock. Why can't it use standard string?
Why can't?
Your mock use standard string. Like, it's a mock.
Yeah.
Why can't it use standard string?
We don't have standard string.
No, you don't have standard string in production. Why in a test environment you don't have standard string?
Yeah, that's a good one. Because we want to run exactly the same code on this RISC file.
And like mocking, your mock file have a standard string and your test using a standard string is not okay for you. Okay. We are testing the real final
production firmware. Of course, this compile stuff will be removed. I agree with you. We are not putting this into production. I solved somehow your. I agree with you. Huh? That's a good point. But then with the same firmware, exactly the same firmware, we can do our tests. We can build it. Okay, we are happy. It builds, so it works for what we know, and now we can run it with QEMU, so an emulation. That's all for now. I think we have 9 minutes. Maybe we can just have a look at the make file, so that maybe it's a little bit more clear. Let's see if I can do this. A little bit more big, right? Yeah, that's basically the flag that is saying, please use the freestanding, so you will have no string at all. As I said, this is ongoing discussion. A lot of stuff has been approved already, so we will have this in some years, but the current version, we need to work like this. So we need to create everything, almost everything from scratch. There are libraries, for example, the embedded template library, that is leveraging a lot of this stuff, but even with the freestanding flags, is not able to compile because it leveraged the C-assert header that is not present. It's leveraging the string.h that is not present. So anyway, you cannot do this. Yeah, that's basically it. I don't know if you have any questions before I...
Why use a make file, not CMake, to benefit from dependency management? It's not going to go to the final machine in any case. So
yeah,
you're cross-compiling, I assume. So
no, this is cross-compiling.
Right, you are.
Yeah.
So you have available something like CMake. Why go through the trouble of keeping yourself to make file and manage everything manually? I know.
Yeah, that's also a good point. So what I did is to leverage the Hello World bare metal recipe inside the Octo project, and it comes with a lot of target architecture, and I just changed the make file, so nothing more than this. But I agree with you. All my other projects I have CMake, but that's another story. So my goal to not letting you falling asleep failed miserably. But
can I make a quick question?
Yeah.
Since you are building, so you don't care about runtime in the end because you do the checks at compile time.
Mm-hmm.
Why in the end do you need to have everything you test has to be const eval? So you have to rewrite everything to make it work during your tests?
Yeah, that's another good point. Of course, when you are building your firmware, these const eval stuff are useless. I agree with you. Because you are reading from registers. Registers can vary, can change whenever they want, and you cannot be const eval. Yeah. So you are just changing. You are using some sort of define that at some point you change in const exp. Yeah.
Can you take
another? Yeah.
You mentioned something, but can you say this again, maybe? Why is const eval what part of what you did cannot be done with regular non-const eval C++? It seems like everything you did could have I would do all the things you did, but without the const eval, and it seems like it should have been okay. No.
Everything can be also const exp, but everything can be also runtime. Yes, but for rapid prototyping, in my case, in my specific case, in a let's say, TDD flow. We discussed about flow yesterday night. It was just simpler, and that's the reason why it's there. It's not mandatory, of course, for the whole stuff. But this proved that you can do a lot of stuff at compile time, and you can have the same code at the end that can run also at runtime. Same quoted, of course.
Thank you.
Good? We can close it then.
You are done.
Yeah.
Okay.
Thank
Thank
you.
you.